Hey, is this what springs to mind when you think of 3D printers? Disappointed that your Klipper printer lacks time-lapse capability straight out of the box? I certainly was, but to my delight, I discovered how simple it was to activate this feature with just a few commands and a pair of basic random $5 webcams. Both my Sobol SVU7 Plus and Klipperized SVU6 Plus now boast this cool functionality. Stick around and I'll show you how I did it and how you can elevate time lapses on your Comgo T300 or other Klipper printers, even if not all features are enabled initially. I'm Gergo, and you're watching Gergo Print 3D, a channel that delves into the 3D printing topics that fascinate me, and hopefully you. Take a look at my SVU6 Plus with the Sobol Klipper screen, now featuring the time-lapse setting in the mainsail interface. Not only can I create hyperlapses, these sped-up recordings of prints, which are not ideal for bat slingers, but with a few clever slicer settings, we can capture snapshots at layer changes and even park the print head out of sight. All your prints can be automatically recorded and found listed here under the new time-lapse menu item. So in this video, I'll show you how to add and configure a webcam. I'll recommend camera mount options for these printers. Then I'll guide you through the installation process for the Moonraker time-lapse plugin in the official Sobol Klipper screen without bricking your printer. We'll configure both your slicer and Klipper in the mainsail interface. And stick around to the end because as a bonus tip, I'll show you how to salvage a broken time-lapse using free software. So let's get right into it. Starting with the good news. Almost any webcam, even the ones you can get for less than $10 on AliExpress, will work with your printer. I'll have a few listed for you in the description below. Just plug it into one of the USB ports of the printer, bring up the mainsail interface in your web browser or Orca Slicer, and add the camera under the camera section of settings. You can name the camera anything you want, and unless the picture is upside down or anything, you can keep the default settings. You might need to restart or reboot the printer or unplug, replug the USB cable, but eventually the camera feed will show up on your dashboard and on this dedicated camera page. Cheap webcams like these are sufficient for remote monitoring your prints and for checking the state of your printer from a remote computer before starting a print job. But I promised time-lapse videos. For those, you probably want to invest into something higher quality. Just compare the footage from my $60 Lenovo 510 and the $7 HD webcam from AliExpress. Though there are a few settings you can tweak to up the quality of either of these. On the machine page, you can download crownsnest.log. And if you scroll to the end, you'll see a list of resolutions your camera is capable of. See, even this potato is capable of producing 1920 by 1080 resolution. While I'm not going that high, let's try this 1280 by 800. Why not the 720? Because 720 just crops out the top and bottom of the picture. You will get a taller view angle with more boxy aspect ratios. Now we'll make a backup of the crownsnest.conf file by duplicating it and adding the current timestamp. Watch my earlier video on recovering configuration file backups in case of any mistakes. We could edit the file right here, but you can also access it directly from the camera settings page. See? So here, we can update the resolution. Just be sure to type a lowercase x and no spaces between the numbers. Cheap webcams might just upscale their crappy picture, but this is a crucial setting for higher-end cameras. Just don't go too crazy with the resolution because you can really bog down your Klipper screen with a lot of image processing. you will need to rev up that cooling I showed you how to add to your Klipper screen. Another must-see video. On to mounting options. It's of course endless, from clipping the cam to the side of your rack to off-the-shelf tripods, and you'll also find an infinite number of 3D printable camera holders. Personally, I love the simplicity of 3D Print Demon's fixed USB camera mount for the Comgo T300, which ingeniously replaces the left side cover of the front panel. I loved it so much that I looked for a similar solution for my other two printers. This camera holder for the SVO6 Plus from Vasco Almeida looked promising, but it turned out to be a nightmare to print and ended up not even fitting correctly on my printer. I basically had to redesign it from scratch for a much better fit, and I also made it printable without supports. So much easier. You will find my improved model in my Cults 3D collection. Designing the camera holder for the SVO7 Plus was a bit more challenging because unlike the SVO6, the SVO7 parts aren't open source yet. Along with the tall and short variants, I printed a number of prototypes this time again to make sure it fits perfectly to the front cover and blends well with the design of the printer. The effect will be perfect if you can print it using Sovo Blue filament. If you want to get some, I've put a link to it in the description below. The complete holder takes about an hour to print using just 30 grams of filament, and for durability, I suggest using a gyroid infill and at least 3 walls. But besides the models, I also included my recommended slicer settings in the Cults 3D project, linked up here and in the description below. You'll also need a pair of 30mm long countersunk M5 screws because the originals would not be long enough. I included a cable channel, zip tie grooves, and a 7mm mounting hole to attach your camera, but feel free to comment your wishes below. I'd be happy to add more camera mounting options. And that's all for the hardware. At this point, you're already set for remote monitoring. But we are here for more, right? The Moonraker time-lapse plugin. And here's the good news for Comgo T300 users. It's already installed on your machine. While its configuration isn't perfect, and we are going to address that shortly, you have the luxury of skipping this step with the installation process. And this is a big relief, believe me, since accessing the eMMC for making a backup of it on the T300 would have been a real pain. So, T300 users, you can sit back and just watch the steps that Comgo has conveniently spared you from. On the Sovos, step 1, back up your eMMC. Seriously. You'll see we are going to install stuff inside the Klipper installation, not just modify config files like printer CFG. If you mess up, you will be out of your printer. And it is easy to mess up, but it's also very easy to make a backup. I made a video about it. Do watch it, and do it before proceeding. Even if it means you need to wait a week for that eMMC reader to be shipped to you before you can make your first time-lapse, don't risk bricking without an easy way back. So, if you already have your backup, the process is pretty straightforward from here. We'll just follow the steps on their GitHub detailed in the installation.md page. On our remote computer, we open a command prompt. I'm doing it on a Windows installation here. We are going to log into the printer using SSH with the username MKS and we put the IP address of our printer here, the same that we use in our web browser or Orca Slicer, found under config network in the Klipper screen. We can't see any characters on the screen as we type the password, which is MakerBase, and press enter. Now, we will enter these 4 lines exactly one after the other. I vaguely understand what these are. First, we go to the root folder, then download the component, then go into the downloaded directory and run the install script. And this is how it went down on my SVO6 Plus Klipper screen. It took almost exactly 4 minutes. It also showed this message on the Klipper screen and rebooted once or twice. Although I got a few warning messages along the way, the greeting "Happy printing" gives us hope. On my identical looking SVO7 Plus installation, running the same commands resulted in error 100. A bit disappointing, but I did find a fix. Hardcore Linux Klipper experts will probably cringe, but this is what I did. For starters, I made sure I had a recent eMMC backup of my Klipper screen. Yeah, I know I already told you to make one, but the chance of bricking your SVO7 Plus at this point has just multiplied. Then, I simply disabled the part of the install script where it attempted to update Klipper and Moonraker to the latest versions, because the error messages I saw seemed to be referring to those. I've seen walkthrough guides on updating them to the latest, and I might even do a video showing you how it can be done, but for now, the Moonraker timelapse plugin doesn't require these latest versions. So, we go to the scripts subdirectory, open the install script in VI editor, and go to the line after step 3, way down in the file. Press I to switch to insert mode and add a hash mark character, this way commenting out the line that calls initial check. See how it turned blue? Press escape to exit insert mode and type :WQ to save and quit. Now we simply repeat the last 2 commands, change back to the timelapse directory and make install. Another 4 minutes and happy printing. If all goes well, we can now go back into the mainsail interface. Let's make a timestamped duplicate of the Moonraker conf file, because continuing in the installation guide, we'll need to copy and add the following lines. Moreover, the configuration guide also instructs us to add this whole time-lapse section here. So again, we can copy and paste at the end of the conf file, leaving a blank line between the 2 sections. Save and close. No need to restart yet. Next, we make a timestamped duplicate of printer CFG. Remember? I explained in my backup recovery video, no automatic backups are created if we manually edit printer CFG. Better safe than sorry. So now we can go ahead and copy and paste the following line somewhere near the top of the printer CFG file. Include space timelapse.cfg between square brackets. And this is when we can save and restart. And if all went according to plan, you too will see the new time-lapse menu item in the side menu. Congrats if you do. I also got this new update section show up on my machine page. I've heard all kinds of horror stories about updating Klipper using these or other automatic methods. Wi-Fi will stop working, the Klipper screen will stop showing information. Again, there are other working ways to update. I promise to make a video if I succeed with one of them, but please don't click on these update buttons here. I warned you. Welcome back, T300 users. You were spared from these hassles, but now on to configuring our slicer and fine-tuning the plugin. Are you still using the Cura slicer that came with your printer, or have you already switched to Orca slicer like I did? I show you the required settings in either case. In Cura, you will have to add a script under Extensions, Post-Processing, Modify G-Code, similar to the filament change or thumbnail images I showed you in my earlier videos. You can guess which script to select here. Yes, time-lapse. But change the trigger command to timelapse_take_frame, as the configuration guide tells us. But you know me, I recommend switching to Orca Slicer, and I made a whole video on why and how to do it. In Orca Slicer, we add the trigger command in the printer settings on the machine G-code page under this dedicated time-lapse G-code section. Our G-code generated by either slicer will now include this macro call following every layer change. In the web interface of the printer, we now have a new settings group for time-lapse. We can enable or disable the time-lapse function, so you don't have to create the time-lapse for all your future prints. And you will even see this same toggle when you start a print from the Mainsail interface or from the device screen of the T300. As far as I know, this option is not shown on the Sovo Clipper screen. Next, we can choose the mode. Hyperlapse would actually work even without the layer change macro, but it produces terrible results on bed slingers, since the time-based snapshots will catch the print bed at different positions for every frame of the video, so layer macro mode is the one recommended. It's not perfect either, but layer change usually happens along one of the seam lines, which tend to be at the same bed position, at least for more simple prints. In Orca Slicer, we can even use the seam painter to place the seam on an aesthetically advantageous part of the model, also considering the time-lapse ramifications of its position. For more complex prints, and if you want to take your time-lapse to the next level, we also have the option of moving the print head to the same position before taking each snapshot. You've seen the option Park Print Head in Cura, and it's also available in the settings here. Just make sure not to do both. 3 side notes here regarding print head parking. It looks amazing, but it will not only slow down your prints, but it can also have quite a detrimental effect on print quality. It's not ideal to travel the extruder back and forth after every layer change. Secondly, you see they let you add retraction before parking the print head. And it indeed makes sense to retract the filament before parking and detract or refill the nozzle when resuming the print, but be careful. Most print profiles already have retract at layer change. If it does, make sure to disable this retraction before parking by putting 0 for both distance values. It's important, otherwise double retraction will pull the filament too far up in the nozzle, which can cause clogging and the failure of your print. So no double retractions. Thirdly, you'll notice the T300 has some of the options disabled, including printhead parking. Again, make a timestamped duplicate of your moonraker.com file, then comment out all the lines starting with the word park. Since so many things are already commented out, notice I'm also adding my name, so I'll know which ones I commented out in this file. After save and restart, you should be able to access these settings on your T300 as well. The fourth note out of the 3 is regarding this option, stream delay compensation. Cheap webcams tend to lag, which would cause the wrong frame to be captured. With this option, we can attempt to account for this delay, but how do we know the value? They've provided a helper macro called test stream delay, which will simply move the toolhead along the x-axis from left to right, pausing in the center for the park time we've set in our settings and taking a picture with our set stream delay. We can check the taken frame on the time-lapse screen, and if the toolhead in the picture is to the right of the center, we know we have to increase the delay compensation value. If it is to the left, we decrease it. When the picture is in the center and sharp, we have the correct value. Increase the park time to make it sharp. This method will not work too well if the delay of our particular webcam is inconsistent. You can keep the rest of the settings as they are, all documented here on the plugins GitHub page. If you've got questions, just ask in the comments below. Chances are I won't know the answer either. I'm still figuring these things out myself, but let's help each other out. The comments are a great place for us to share tips and fix any mistakes. Let's learn together. With these settings, your prints will be filmed as long as you have the time-lapse enabled. Thanks to the auto render option, the new videos will show up in the time-lapse screen a few minutes after your print finishes. If not, even several minutes later, you might have turned off the auto render option, but no worries, you can also do it right here manually. But only for your most recent print. So auto render is much safer. You can watch the recording here, though it could look choppy depending on your network speeds and your choice of resolution. It's always better to download it and play it on your computer. Again, I have 3 little notes for this. For one, you'll notice download only works from the web browser, not from the device tab in Orca Slicer. 2, these videos take up storage space on your printer. We've only got 2 gigabytes. Be sure to delete the ones you've already downloaded. And 3, you can mark multiple to download, but remember, it will need twice the space and it might take a few minutes to make the zip file. If you run out of space, just download and remove them one at a time. And with this, we've arrived to my bonus tip, which is also related to this screen. What if your print completes and the video fails to render even when started manually? Well, it happened to me. My cheap camera was acting up. Turns out, even if just a single frame is corrupted, the whole render will fail. Very frustrating. It can be almost as devastating to lose a time-lapse as a failed print. You might need to redo that whole print in either case. Don't worry though, there is a good chance you can salvage the footage. First, if your camera flickers like this right from the beginning of the print, it's not too late to cancel and restart. I discovered plugging my camera in the side USB port fixed the flickering for me. Some forums suggested adding the following options in the extra output parameter field. Then re-render. It didn't really help me, since even with these options, it will only render to the first missing frame. But we can still get the individual frames and compile them into a video using a capable video editor. And I'll show you with the free version of DaVinci Resolve. Immediately after the failed recording, you can click Save Frames, then download the generated zip file in a web browser. Extract the frames to a folder on your computer. Weed out the corrupted frames either in thumbnail view or simply by sorting the frames by file size and deleting the smaller ones. Now make sure to resort them alphabetically. Select all and rename. DaVinci Resolve wouldn't be able to handle the image sequence if the numbering is not continuous. You can get DaVinci Resolve from the official website. And it's not just a trial version either. This is the video editor I'm using for my YouTube videos as well. In DaVinci, create a new project. Switch to the Media tab at the bottom, the very first one. In the overflow menu of the Media storage panel, set the frame display mode to Sequence. And drag and drop the folder containing the frames into the media storage. From here, drag them into your media pool. Switching to the Edit tab at the bottom, we drag the clip from the media pool onto the timeline. You can already preview your video. If you still see some bad frames, you can go back and remove those frames from your folder and re-import them into DaVinci. But if you like what you see in the preview, you can go to the tab called Deliver at the bottom, select the YouTube option, set a destination file name and location, then add to render queue, and in the render queue panel, click render all. Not the simplest, but doable. Amazing, isn't it? I was so excited when I realized this was all possible and not even that difficult. I'm sure you will manage. And please share your time lapses on YouTube and other social media. If you put it on YouTube, just leave a comment. Google won't allow links, but we can click on your icon to view your channel. I don't know about you, but even after 5 years in this hobby, I still enjoy watching these prints in action. Don't start without a proper backup though. If you haven't yet, be sure to watch my videos on backups. And according to analytics, this is my best next video for you. So keep watching or go print 3D. Aren't you gonna click?